Pi plays Pokemon, or any game for that matter.
So in this video they ask the following question: can you find in the digits of pi a perfect run, a perfect speed run of a video game, for example, Pokemon? So I have no idea how to play Pokemon, in particular this game, but what they're doing is assigning to every digit of pi, they are assigning one motion in the game, and then say it takes 1,000,000 steps to complete the game. Is there a string of 1,000,000 digits that will give you a perfect speed run of the game? So the question is that there is a specific string of 1,000,000 digits that we're looking for, and is that specific string in the digits of pi? And the question is that we don't know, but we think so. And your phone number and your credit card number and a book that describes your entire life, that is in the digits of pi, conjecturally. So what we conjecture is that pi is a normal number. And what that means is that it's normal in its decimal expansion, and meaning that in the decimal expansion, every digit appears uniformly. So every digit appears just as often as any other digit. And in fact, any string of n digits, any particular string appears as often as any other string of n digits. So if you fix a number n and you fix strings of n digits and you fix a particular one, that one will appear as often as any of the other possibilities in the long run. Again, this is not known, this is conjecturally, but what we do know is that most numbers, in fact 100% of all the irrational numbers, are normal, meaning that if you pick an irrational number at random, it will be normal and it will satisfy this property. Since there is no reason to believe that the numbers in the digits of pi follow any other distribution, we think that the distribution is uniform and that pi is normal and that this behavior occurs. Let's experiment with this. So if you look at the first 100,000 digits of pi, we conjecture that every digit will appear equally distributed as any other digit. So if you divide 100,000 by 10, there should be that every digit appears about 10,000 times. And if you do the actual count, this is what happens: that 0 appears almost 10,000 times, that 1 appears approximately 10,000 times, and so on. Not exactly 10,000 times, but it starts to approximate the distribution we think it should follow. Similarly, if you look at blocks of 2 digits, since there are 10 times 10, 100 blocks of 2 digits, in the first 100,000 digits, we expect to see about 1,000 times each block. And if you see, for example, 05 appears about 1,000 times, or 94 appears about 1,000 times. So this is why we think that pi is normal, because of the data we see and because there is no reason for it to be distributed in any other way.